Hello everyone, myself Mounika. I am doing my Masters in Computer Science at Manasa Gangotri, University of Mysore. In this session, I am going to explain about decision tree classifier in machine learning. Before going to the session, let us see what are the topics I am going to explain in this session. Introduction to decision tree classifier, algorithm, attribute selection measures, construction of a decision tree using information gain, construction of a decision tree using Gini index. Decision tree classifier. Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. It is a tree structure classifier where internal nodes represent the features of a dataset, branches represent the decision rules, and each leaf node represents the outcome. It is called a decision tree because it is similar to a tree. It starts with a root node which expands on further branches and constructs a tree-like structure. In a decision tree, there are two nodes, which are the decision node and the leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branches. The decisions or the tests are performed on the basis of the features of the given dataset. It is a graphical representation for getting all the possible solutions to a problem or the decision based on given conditions. A decision tree simply asks a question and based on the answer yes or no, it further splits the tree into the subtrees. Note: a decision tree can contain categorical data, that is yes or no, as well as the numeric data. This diagram, it explains the general structure of a decision tree. Here we can see that in this diagram we have two types of nodes, that is decision nodes and a leaf node. As I told earlier, in decision tree we have decision node and leaf nodes. So decision nodes are nothing but these are used to make any decisions and which can have multiple branches, whereas leaf nodes are nothing but these are the output of those decision nodes and which cannot contain further branches. Let us see how does a decision tree algorithm work. Step 1. Begin the tree with the root node says S, which contains the complete dataset. Step 2. Find the best attribute in the dataset using attribute selection measure ASM. Step 3. Divide the S into the subsets that contains the possible values for the best attributes. Step 4. Generate the decision tree node which contains the best attribute. In the step 5, recursively make a new decision trees using the subsets of the dataset which was created in the step 3. Continue this process until a stage is reached where you can't further classify the nodes and called as final nodes as a leaf node. Example: suppose there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. So in order to solve this problem, the decision tree starts with the root node, salary attribute by ASM. The root node splits further into the next decision node, that is distance from the office, and one leaf node based on the corresponding labels. The next decision node further gets split into the one decision node, that is cab facility, and one leaf node. Finally, the decision node splits into the two leaf nodes, that is accepted offer and declined offer. Attribute selection measures. While implementing a decision tree, the main issue arises that how to select the best attribute for the root node and for the subnodes. So in order to solve such a problems, there is a technique which is called as a attribute selection measure or ASM. By this measurement, we can easily select the best attribute for the nodes of the tree. There are two popular techniques for ASM, which are information gain and Gini index. Information gain. Information gain is a measurement of changes in the entropy after the segmentation of a dataset based on an attribute. It calculates how much information a feature provides us about a class. So according to the value of information gain, we split the node and build the decision tree. A decision tree algorithm always tries to maximize the value of information gain, and a node or attribute having the highest information gain is split first. It can be calculated using the below formula, that is information gain equal to the entropy of S minus weighted average into the entropy of each feature. So if we are constructing a decision tree using information gain, we have to take the best attribute which is having the highest information gain. Entropy. Entropy is a metric to measure the impurity in a given attribute. It specifies randomness in data. It can be calculated as entropy of S equal to minus P of S log to the base 2 of P of S minus P of no log to the base 2 of P of no, where S equal to the total number of samples, P of S equal to the probability of S, and P of no is equal to the probability of no. So in a simple verse, entropy, it tells us that the number of positive examples and the number of negative examples in the given data set. Here we can see that if number of S equal to the number of no, that is probability of S equal to the 0.5 and entropy of S will be the 1. If it contains all S or all no, that is probability of S equal to the 1 or no, then the entropy of S will be the 0. So this will be helpful when we are calculating the entropy for the attribute. Gini index. Gini index is a metric to measure how often a randomly chosen element will be incorrectly identified. It means an attribute with lower Gini index should be preferred. Sklearn suppose Gini criteria for Gini index, and by default it takes a Gini value. The formula for the calculation of the Gini index is given below. So by using this formula we can calculate the Gini index for the attribute. So if we are constructing the decision tree using a Gini index, we have to take the attribute which is having the lower Gini index first. Construction of a decision tree using the information. Here we can see that we have one problem, that is make a decision tree that predicts whether tennis will be played on the day or not. This is our problem. We have to construct the decision tree in order to solve this problem. Here we have given data set. In this data set we have 5 attributes, that is outlook, temperature, humidity, windy, and play tennis. Here play tennis is a class attribute and this is the output. So this attribute, it depends upon the value of 4 attributes, that is compute the entropy for the data set entropy of S. So at the first step we have to calculate the entropy for the data set. At the second step, for every attribute or the feature, calculate the entropy for all other values entropy of A. See, we have to calculate the entropy for all the features of, for all the values of that attribute. Then take average information entropy for the current attribute. Then we have to calculate the information gain for the current attribute. Like this, we have to find the information gain for all the attributes which are present in a data set. Then pick the highest gain attribute, and we have to pick the attribute which is having the highest information gain. Then we repeat until we get the tree which we decide. So we go on repeating this process until we get the desired output. Here we can see that at the step 1, compute the entropy for the data set. So here this is our data set. We have to compute the entropy for this data set. Let us see how we can calculate the entropy. Out of 14 instances, we have 9 yes and 5 no. So by using formula, that is this is our formula for the entropy. By using this formula, we can calculate the entropy, that is probability of S. So how many S we have? 9. So probability of S will be the 9 by 14 into the log to the base 2 of 9 by 14 minus 5 by 14 into the log to the base into of 5 by 14. So entropy of S will be the 0.94. Here we can see that which node to select as a root node, whether among all 4 attributes, whether we should take outlook as a root node or temperature or humidity or windy. Let us consider the outlook attribute. For the outlook attribute, we have 3 values, that is sunny, overcast and rainy. So for sunny we have 5 instances, for the overcast we have 4 instances, all are S. For the rainy we have 2 S and 3 S and 2 no's. Let us see how we can calculate the information gain for the outlook attribute. As I told earlier, we have to find the entropy for each value of the attribute, then we'll take the information from that attribute, then we will find the information gain. So entropy for the sunny value will be the 0.997 and the overcast will be 0 and the rainy will be the 0.97. So these values according to the formula, so we will get these values. Information from the outlook, that is for each value we will take the average, that is for sunny how many instances we have? 5 out of 14. So 5 by 14 into the entropy of that value is 0.971 plus for overcast we have 4 instances. So 4 by 14 into the entropy of the value will be the 0 plus for rainy 5 by 14 into the 0.97. So this is our information from outlook is 0.693. So from this we can calculate the information gain. According to the formula, entropy of S, that is entropy of the data set will be the 0.94 minus I of outlook, that is information of outlook will be the 0.93. So how much we will get? 0.24. Like this we will calculate the information gain for the all attributes. Let us calculate the information gain for the windy attribute. For the windy attribute we can see that we have the only two values, that is false and true. So for the false, how many instances we have? 8 instances out of 14, and for the true we have 3 are yes and 3 are no instances. Here the entropy of the windy attribute when it is true, that is 1, and entropy of windy when it is false value, then it is 0.811. So information from the windy will be the, for false how much we have? 8 instances, 8 by 14 into the entropy of that 0.811 plus 6 by 14 into the 1. This is the information from windy will be the 0.89. Information gained from the windy will be the, so 0.94 minus 0.89 equal to the 0.048. So this is the information gain for the windy attribute. Similarly, we calculate for the rest too. After finding the information gain for all the attributes, that is outlook, temperature, humidity and windy. So this is our information gain values, that is for outlook we have 0.24, for temperature 0.029, for humidity 0.15, for a windy 0.048. So here we can see that among all 4 attributes, outlook attribute is having the highest information gain. So as I told before, when we are constructing decision tree using information gain, we have to take the attribute which is having the highest information gain as a first. So since outlook is having the highest information gain, outlook is our root node. Here we can see that outlook is at the root, and for the outlook attribute we have 3 values, that is sunny, overcast and rainy. When the outlook is overcast we can play the tennis because all instances are S. But in the case of sunny and the rainy values, in sunny we have some of S and some of no, and also in rainy we have some of S and some of no. Again we have to find the best attribute for the sunny value and also for the rainy value, and then we will go on splitting according to the conditions. Repeat the same thing for the trees till we get the tree, that is when the outlook is equal to the sunny. So we have, that is temperature, humidity and windy. So among these 3 attributes we have to find the best attribute, that is which is attribute which is having the highest information gain by following the same procedure. That is we have to find the entropy of the data set, then we will find the information gain for each attribute, then we will find the attribute which is having the highest information gain, and then we will take that attribute as a best attribute. And also for the outlook equal to rainy, that is when the outlook is rainy we have to find the attribute which is having the highest information gain in the same procedure. So at the last, this is how our complete tree will look like. So when the outlook is sunny and when it is humidity, when the humidity is normal, we can play the tennis, but when the humidity is high, we cannot play the tennis. When the outlook is overcast, we can play the tennis. When the outlook is rainy and when the windy is weak, we can play the tennis, and when the wind is strong, we cannot play the tennis. So this is a solution to the given problem. Construction of a decision tree using Gini index. Example, let's consider the dataset in the image here and draw a decision tree using the Gini index. So this is our given data set. By using this data set, we have to construct the decision tree. Here we have 5 attributes, that is attribute A, B, C, D and E. In the data set, there are 5 attributes, from which attribute E is a predicting feature which contains the 2 positive and negative classes. We have an equal proportion for both the classes. In Gini index, we have to choose some random values to categorize each attribute. These values for this data set are, so from this table, for each attribute, we are randomly choosing some values. So for A, the value is greater than or equal to 5 and less than 5. For B, value is greater than or equal to 3.0, less than 3.0. For C attribute, value is greater than or equal to 4.2, less than 4.2, and for D attribute, value is greater than or equal to 1.4 and the value is less than 1.2. So these are the values we are taken randomly in order to categorize each attribute. Let us see how we can calculate the Gini index for each attribute. So in order to find the Gini index for the attribute A, so we have two conditions, that is the value greater than or equal to 5, value is less than 5. So when the value is greater than or equal to 5, we have out of 16 instances we have 12. So in that 12 we have positive 5 and 7 negative. So that is Gini index of 5, 7 will be the, according to the formula, when we apply formula, we will get the Gini index as 0.48. So when the value is less than 5, that is out of 16 we have 4 instances. In 4, 3 are positive and 1 is negative. So Gini index of 3, 1 will be the 0.375. By adding weight and sum of each of the Gini indexes, so we are adding those values, that is 12 by 16 into the 0.486, that is when the value is greater than or equal to 5, plus when the value is less than 5, that is out of 16 how many we have? 4. So 4 by 16 into the Gini of 3, 1 will be the 0.375. So Gini index for the attribute A will be the 0.485. Similarly, we also calculated for the attribute B. In the same procedure, we will follow. Using the same approach, we can calculate the Gini index for the C and the D attributes. In the same way, we will calculate the Gini index for the attribute B, C and D. So after finding the Gini indexes, our Gini index values are like this. I think you can clearly understand this diagram. So this is our output, that is decision tree for the data set. As I told, when we are using the Gini index, we have to take the attribute which is having the lowest Gini index. So in this diagram, we can see that the attribute C is having the lowest Gini index. So we are taken as a root node, that is it is having the lowest Gini index. And the next one is D, B and A. So this is our decision tree for the given data set. At the last, advantages of the decision tree and the disadvantages of the decision tree. Advantages. It is simple to understand as it follows the same process which a human follow while making any decision in real life. It can be very useful for solving decision related problems. It helps to think about all the possible outcomes for a problem. There is less requirement of data cleaning compared to the other algorithms. Let us see what are the disadvantages. The decision tree contains lots of layers, which makes it complex. It may have an overfitting issue, which can be resolved using the random forest algorithm. For more class labels, the computational complexity of the decision tree may increase. Thank you everyone.